Good morning. I'm going to share with you the Engineering Center at Oakland University. This building consolidates what was once previously dispersed engineering functions across campus into one building, creating a visual icon for the School of Engineering. We wanted to really enforce interdisciplinary collaboration amongst the students, as well as support the future evolution of engineering. We also asked ourselves, how can the building itself become a learning tool for the students? How can they learn from real-world engineering? The building is situated into a hill that slopes from the south up to the north, and in addition to the typical classrooms and labs, it has a clean room, a full-service machine room, an outdoor work yard where students run robots across obstacle courses, a high bay lab, and a rooftop lab where students conduct experiments on solar and wind generation. Conceptually, we looked at two expressions of engineering. On the one hand, you have the more streamlined, concealed, minimal expression, and the other side is this more tinkering garage workshop. So the faculty offices express this streamlined version, whereas the student spaces are more of that tinkering garage. Each face of the building responds to its solar orientation. So on the south side, we have a 5-story atrium with horizontal louvers, and then this cantilevered block here is the faculty office wing, and it has that more streamlined effect with the gradient transparencies of glass. On the west side are the student labs, and it has this more industrial feel with the zinc panels, the precast concrete panels, and then the rhythm of the vertical louvers. We have a series of large glass folding doors that connect the high bay lab to that exterior work yard. Because of where the building is situated on campus, it becomes an integrated part of the campus circulation. So we wanted to enhance that experience as you walk through the building. This is a view below that cantilevered office block. So we're framing the view south over the horizon of trees and then using transparency to connect into the interior of the building. So I'm going to give you the quick, dumb architect version of our energy efficient tri-generation system. These two turbo generators create 200 kilowatts of electric power and heat, which provides the emergency power, the normal power, and then any surplus power gets sent to the rest of campus. Hot turbine gas goes through boiler system or whatever that heats the building during the winter and then runs chillers in other buildings during the summer. I'm not a mechanical engineer. So from a material palette, most of the materials are gray. You've got the concrete masonry, the precast panels, the steel, the metal mesh. We wanted to really focus and highlight the student areas where students really engage with the building with these bright pops of color, providing a nice contrast between the two. This is a view in the main lobby, which we saw as more of a gallery type space where students can exhibit the projects that they've worked on, whether it's SAE cars, helicopters, drones, and we also wanted to call attention to the engineering of the building. We've got this delicate stair that is balanced on this beam, hung from the structure above, to get students to think a little bit more about their space. And in order to facilitate that collaboration outside of the classroom, we have a variety of these informal gathering spaces. Here's two views here of that wood wrapping bench idea, and the image on your left shows this bright painted red steel rotating partition with a whiteboard on either side, and it almost begs students to actually open and close this door to manipulate their space as they need. They can either separate this little space into two, or they can separate it off of the corridor. So we asked, how can we use the building itself as a learning tool for the students? They actually monitor the efficiency of the electrical and mechanical systems. And because many of these systems are exposed, there had to be a really strong collaboration between our engineering team and our architecture team to really make it a true mode of learning. I had a student come up to me and ask me if I was the architect. She said that this building made her want to be an architect because it got her thinking about all of these systems that are typically concealed. And she said especially water, like she was just so excited to be a student in this space. This is a view of what we call the chamber. It's a 200-seat classroom on the ground floor, tucked into the hill. We use these really heavy, robust steel doors as the entry, and then the material palette is generally a darker color, and the wall sconces along the side of the walls resemble torches. And then the classrooms in the rest of the building, they're higher up. They have this diffused natural daylight that comes into the space. So similar materials, but lighter in color. We're using that wood wrapping element to warm up the space. And then these are actually chilled beams, not diffusers in the ceiling. It's a more energy efficient mechanical system. We also designed the labs to be flexible so that they can expand and contract as the school needs. And this is a view of our high bay lab. We had the question of what could a student potentially do and how can we provide the space for them to do it, whether it's fly helicopters or drones, lift heavy equipment. We had a faculty member ask us when we were going to paint the concrete block because we left it exposed, and he said it looked unfinished. And we said, well, what do the students think? And he said, well, they like it. So we said, okay, that's your answer. We're gonna leave it unfinished, and there's this nice contrast from the raw materials to these bright pops of color. So the school really has become this visual icon for the School of Engineering, and in doing so, they've recruited many more students as well as renowned faculty. And the hands-on collaborative approach is really better preparing them for the workforce. Thank you.